Hey, what's up, guys? Yeah, so this question is I recently encountered, and I think it's interesting, and it's not difficult, but words to for make a small video. So probability that some independent random variable less than one. So the situation is that we have uh, x1, xn. They are both random variable, uniform random from 0, 1, and we want to ask what's the probability that x1 up to xn less than 1. So each x1, x2 up to xn are drawn from random 0 to 1. Okay, so this problem has various ways to solve it. So let me just provide a solution 1. Solution 1 is that somehow like geometrical. So when you encounter this problem, yeah, you can start from the small one. So for example, you can ask what is probability of x1 plus x2 less or equal to 1. This is very simple, right? Because, or let's say x less than t, and then suppose t is less than 1. So this is x1, x2, and then there are 1 to 1. There are from 0 to 1, and then less or equal to t, right? So it's this maybe here, and then this is t, this is t, right? So this area is just t squared divided by 2. Okay, so it's just very simple, right? You prove. So the answer is t squared divided by 2. And obviously that you can, this is the CDF, right? So you can do the differentiation. So let's say respect t. Let's call s to be the random variable of x1 plus x2. Then your f prime f s prime differentiated by t will be just 2t. Okay, so this is just the CDF. This is PDF, probability density function, and then this is CDF. Okay, so if you go higher, then it's very simple, right? Because let's say you want to ask what is the probability less equal to t for three random variable. If t is less or equal to 1, then this is also very simple. You start from x1, x2, and 3, and then you know that this will be a tetrahedron, right? So it will be t, 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 and then you can compute the volume of it. The low volume of just t squared divided by 2, which is the bottom times the height, 1 divided by 3, so it's t cubed divided by 6. Okay, now you can also compute this. You can define s to be x1 plus x2 plus x3, and then you do the differentiation respect to t, then you get t squared divided by 2. Okay, and now you can go to higher, right? You just try to prove the higher. So you can prove the higher. You want to compute this. Let's call you want to compute this. That's equal to t. Okay, but in general, obviously that it will become the higher dimensional object, and you can use calculus to do this. But from this point, from up to now, that I can prove it by use mathematical induction. So I can assume. So my assumption is that I can assume that the density, the if you have n of them, then the PDF will be the, sorry, there's no derivative. So this answer, let's make assumption. So my assumption is that I want to prove it by mathematical induction. So my assumption is that this probability of x1 up to xn less equal to t will be t to the n divided by n factorial. And this will be, so if n is 2, it's t squared divided by 2, and it will be this. Okay, so this is my assumption, and I already proved that it works for n equals to 1 and 2 and 3. Okay, and I want to assume this is correct and show this is correct, right? This is the standard mathematical induction. So which is very simple. I calculate the probability x1 up to xn plus 1 less or equal to t. This is the same as I do the probability of x1 that's up to xn plus 1 less or equal to t, and I condition on this xn plus 1. So I want to do the uniformly random, so it's f of fn plus xn. So this is a uniformly random density, the probability density function on xn plus 1 and integral xn plus 1. Okay, and obviously that this guy can at most go to 0 to t minus xn plus 1. Okay, then by this, I can write as 0 t minus xn plus 1. And this is probability of x1 up to xn. That's equal to t minus xn plus 1. So I can use the previous assumption. So this previous assumption tell me that I can use this, right? So it become t minus xn plus 1 n factorial. And this is uniform random, right? Skip txn plus 1. And sorry, there is no list because I can at most I already condition it, right? So I only go to t. Okay, so this is what we just need to compute, and it's very simple to prove it. Let's do this. So we get 0 to t minus xn plus 1 and n factorial dxn plus 1. Let's do yeah, you can easily obviously that you can easily do this, right? This just be t minus xn plus 1 plus 1. Because you can write these guys t minus xn plus 1. There is a minus 1 term here, right? So it is. Okay, so you will become t to the n plus 1 n plus 1 factorial. Prove it. Solve. Okay, so now let's talk about solution 2. Okay, so solution 2 is like more systematically. So you want to, let's say your z equals to two random variable sum. So you want to compute the probability of this guy less equal to z. Okay. That's equal to t. Sorry. Let's use this. And let's call this fz of t. Okay, now this guy can be written as the density, the two probability function. So x and the y, and this is y. Okay, and the dx dy. Okay, so now let's write dy and dx. Okay, so you can make x to be in general, you can make x to be minus infinity to infinity, and then your y, right? Your y can force to be minus infinity to t minus x. Okay, right? Because there are less or equal to t. Okay, so up to here, up to now, that you want to make a change of variable, right? You can let z small z to be x plus y, right? So this will be negative infinity, and t negative infinity, and f of x, f of y, and then now you change y to be z minus x, and the dz dx. Okay, now you can do the differentiation respect the t, right? Because you first do the swap the integration. Maybe you need to worry about whether you can swap integration or not, but suppose you can. Okay, so now you do the differential respect to z, small z, then not small z, not t, right? Because this is differentiation. Now you respect the t, because z is a force, fixed number, right? So you get df z t dt will be by this one, right? You get this by the fundamental theorem of calculus. So you get infinity to infinity, f of x, f of y, t minus x dx. Okay, so this is the results. So this is your PDF. So for example, if you start from, let's say, x1 plus x2 is equal to t, let's say n equals to 2, then you just plug the formula for it, right? So you get infinity to infinity, and now each is 1, right? Because 1 times 1, but you do, and the dx, right? But now you force x to be, can at most go to t. So you change the correct one, which is t squared divided by, which is t. It's t. Okay, so this is the f2, and then you can also, so f2 is t squared divided by 2. It's the same as what we derive. And then now you can do f of 3, which you plug your, now become x, right? You become x, And then the second one is still 1, right? So 1 dx, and you go to 0 to t. Then you get very trivial, get t squared divided by 2, and the f3 is t cubed divided by, just do the integration, divided by 3 factorial, and you can keep going. So obviously your f4 will be, you just plug this one, you get x squared divided by 2, 1 dx, 0 to t, then you get the t cubed divided by 6 factorial, and f4. So from this, you can just keep iterating and use this formula, and it will generate the correct answer. Okay, that's it. See you guys next videos.